Having worked with some examples of parabolas or radical functions, let's now go back and find the inverse again of a linear function. Here we're given f of x equals 4x minus 3, a linear function with a slope of 4 passing through a y-intercept of negative 3. Take a moment to sketch the graph of its inverse, state the coordinates of the invariant points, and then determine the equation for the reflected graph, which is to say the inverse. Let's first treat the reflection by changing all points xy to yx. Now, it's important to note, I've gone through this kind of quickly, but the reflection in the line y equals x is equivalent to the question saying, what is the inverse? Here, I've exchanged the x and y coordinates for the 4 points that were indicated. Really, any two would have sufficed, given that we're just graphing a line. In order to determine the invariant points, we can either graph the line y equals x, or in this case, just find the intersection point at 1 and 1. We see here, this is the only point for which the x and y coordinate are both the same. We're asked to determine the equation for the reflected graph, that is, the green line. Now, because it's a line, we have many strategies. We could determine the slope and use the form y equals mx plus b, subbing any point to find the b value. We could use slope point form, but here we're going to take the original equation, f of x equals 4x minus 3, and treat it as its inverse. After switching x and y, we isolated y. Because we got to y equals x plus 3 over 4, but wanted it to be an mx plus b form, we split this into two separate fractions, x over 4 plus 3 over 4. And x over 4 is the same as saying 1/4 x. So we see that the green line can be described by 1/4 x plus 3/4.